So we're used to what we call the vertical line test for a function. However, we can take a function as it is and do what we now call the horizontal line test, which is no different than the vertical line test. You take a vertical line, if it hits the graph more than once, okay. If we do the horizontal line test, that is not going to tell us if it's a function because, well, it might be a function to begin with because it passes the vertical line test, but what the horizontal line test instead does, it helps us find out if there's an inverse to this function. A function f has an inverse if no horizontal lines intersect the graph more than once. Because remember, when we find the inverse, we switch x's and y's. So now if the graph, when I switch x's and y's, becomes right side up, it might hit the graph more than once when I do the vertical line test. But I can do that ahead of time and do the horizontal line test, and I find out, hey, is there even an inverse to this thing? It can only have an inverse if no horizontal line intersects the graph at more than one point. That kind of function is what we call one-to-one. A one-to-one function is a function where no x values or y values repeat. That means it passes. A function has an inverse. A function f has an inverse if and only if it is one-to-one. And again, if and only if, when it comes to math, we like to get lazy and abbreviate if of a. So if and only if, that means no exceptions. It is one-to-one. That means if it's one-to-one, it's going to pass both horizontal line test, HLT, and the vertical line test, the VLT. You can only have an inverse of a function if it's one-to-one, meaning that it passes the horizontal line and the vertical line test. It means that the x values or the y values do not repeat. There is no exception to this. If and only if it passes both the horizontal and the vertical line test. That is the only way you know that you have a function that has an inverse. I mean, the function itself, we know. That's the function passes the vertical line test, that's fine. But it might not have an inverse. That's where the horizontal line test comes in. So let's take a look. Horizontal line test. Is this a function, first of all, for this one on the left? Well, f of x. Don't really have to question that. However, and you can try that out if you want. Here's my vertical line, and my vertical line does not hit the graph more than once anywhere. So that's fine, that's great. But then if I take my horizontal line, doesn't matter where I put that horizontal line, only hits the graph once. So this is a function. This does have an inverse because it passes the vertical and horizontal line test. This next one, although f of x is equal to x squared minus 1, it's a function based on just the notation to begin with. They're telling you that, but we can verify it because it passes the vertical line test. But the problem that we run into is not the fact that it passes the vertical line test or not. We know that this function right here does not have an inverse because this function right here does not pass the horizontal line test. So if a horizontal line connects at more than one point, the function itself does not have an inverse. So x squared minus 1 as it is cannot have an inverse because it will fail the vertical line or the horizontal line test. It passes the vertical but fails the horizontal. So the function is fine, but no inverse. So let's check and see, do these graphs have an inverse function using the horizontal line test? Will these pass both the horizontal and vertical line test? So what I want you to do is I want you to try to graph these. We're not going to make a table of values. You can use any graphing utility to get a quick sketch. Go ahead and pause and take a look at these graphs first. And then when you are done, come back and check, because here are the solutions. So the graph of 1/2 of 3 minus x. If you're looking at this, roughly half of 3 is 1.5. So this graph crosses somewhere around here. The slope is negative 1/2. So quick sketch is just something like that. Will it pass both horizontal and vertical line tests? I don't know. Let's find out. We take a vertical or horizontal line. Looks fine. Take a vertical line. Looks fine. You can move it around. Doesn't matter. Not going to hit the graph more than once. So is this a function? Yes. Does this have an inverse? Yes. Look at the next one. Good old absolute value equation. Absolute value looks like this. V shape, very sharp, where the line y equals x is not allowed to go into the negative values for y. So all the values of y are positive. Is it a function? Well, it says f of x, so sure. As you notice, vertical line passes. But look what happens with the horizontal line. Is it a function now? We notice it hits the graph here. Hits the graph here with a single horizontal line. This is not a function. Or it is a function but does not have an inverse. The inverse would not be a function. We take a look at the next one. The next one is x to the 4th power plus 2. So this one has been shifted up 2 spots from what would have been x to the 4th power. Really sharp parabola looking thing with between 0 and 1 is kind of flattened out, because again, fraction, a number over a fraction with the 4th power gets up very fast. But around fractions, again, that bottom number is very large. So it's closer and closer to 0 until you get around 1, and then it just takes off. Now, if we check to see if this is a function, we see that, oh, it's going to work. But if we see if it has an inverse, the horizontal line test, not going to work. This will fail the horizontal line test several spots. Just the one that I picked, which is right there, is a clear show where it does not. All right. Last but not least, we have f of x is equal to the square root of x. Now, because this one has been limited, this one is now only positive values for x. This graph, the rocket, looks like this. This will pass the vertical line test, but it will also pass the horizontal line test. Now, I know you're probably thinking, well, no, it's flattened out. It's going to hit the graph more than once, right? No. It's increasing very slowly, but it is in fact increasing. It will not come back onto itself. So yes, this is a function. The inverse will also be a function. All right. So in creating a function and its inverse, sometimes from a table, just like we saw when we were graphing earlier, all we have to do is switch x's and y's. So let's take a look at x and f of x being equal to x squared. So the y values from that list is -2, 0, 1, 2. They went ahead and did 3 as well. I usually stop from -2 to 2. But these are the numbers we get. To create the inverse, we switch x's and y's, right? So switching x's and y's, instead of -2, 4, it becomes 4, -2. Notice, in more than one occasion, but notice here that these values repeated. Now I have a repeat x value when I create the inverse, which is exactly why we do the horizontal line test. The horizontal line test sees if I have repeats on the y values before I switch them, because those repeats from y, when I try to create the inverse, now becomes my x values repeating, which we learned a long time ago is not okay for functions because it will fail the vertical line test. So now the horizontal line test keeps us from having to switch first. Just test and see if we even should bother switching. So f of x squared is not 1-to-1. It is not going to have an inverse unless, we saw earlier, we took x squared and square root of x and we created an inverse, right? Well, we can only create an inverse unless, and it won't have one unless you restrict the domain. Which is exactly what the square root needs. For that matter, if I only look at 0 and above for x squared, it's not a full parabola, but now I will create values that work. Because if I take just numbers above 0, I won't run into this repeat right here. Or even this repeat right here, and so on. That's the only way that can happen. So if I take these out of the equation, now I will have a 1-to-1 function. Otherwise, as is, f of x squared, f of x equals x squared does not have an inverse. Now, that's fine if we have graphs, we can look at it. It's fine if, we have a table, we just switch x's and y's. But sometimes, we don't even want to do composition of functions. Sometimes we don't know what the second one looks like. So we might not be able to say, okay, I'm just going to do this and switch things around. But how do I create the inverse knowing that f of x is equal to 5 minus x over 3x plus 2? So we graph it to see, first of all, should we even bother? It will pass both the horizontal line test and the vertical line test. So we go ahead and get started. What is step 1 in writing the inverse of a function? Well, we're going to switch x with y and solve for y. But I don't have that right now. I have f of x. So step 1, we have to write this as y equals. Remember, f of x and y equals are exactly the same thing. So step 1, instead of f of x, we're going to say y equals. Then, once I have y equals, I can now, as it says up there, switch x's and y's. Just every time I see an x, there's a y. Every time I see a y, there's now an x. So that means x equals 5 minus y over 3y plus 2. That's kind of complicated because now I have way too much going on there. And I have y on top and bottom of a fraction. I gotta try to clean this up somehow. And how do I clean up an equation so I can find out what y is equal to? Well, I gotta find out what y is equal to. Solve for y. And in doing so, it gets a little bit complicated. First of all, I want to go ahead and write this as over 1, so I have fraction equals fraction, because that's an easy way to solve equations when they're both fractions, because we simply just go through here and we can just cross multiply. It's one of those things we learned in like pre-algebra, I think. So I take x times 3y plus 2 and 1 times 5 minus y. Well, 5 minus y. Also, if you don't like the idea of cross multiplying, you don't have to put that over 1 to get rid of a denominator, to get rid of divided by 3y plus 2. I can multiply both sides by 3y plus 2. It's the same result. It's just a matter of what stands out to you. Most people like the cross multiplying because that's something we learned early on, right? Now, the next thing I have is I gotta try to get the y's together. But now this one has an x in front and a plus 2, so what I might want to do is this. What happened? Well, they took x and multiplied by 3y. They took x and multiplied by 2. That makes it 3xy plus 2x equals 5 minus y. Now, if I'm solving for y, I got to get everything that has a y to the same side of the equation. That is, I'm going to add y, and add y, well, doesn't have anywhere to add to. Cannot add it to 3xy because that has an extra variable. So I'm just going to add y kind of off to the side a little bit. And then at the same time, if you want to save yourself a headache, you can subtract 2x, which means I'm going to subtract 2x here. All right, again, there's nothing for me to combine the 2x with, so it's just kind of floating around for now. So now I have 3xy plus y equals 5 minus 2x. Finally, I have y in both of these terms here. So what I can do is take the y value out from each one. I'm factoring out the y because I'm almost done now. Y parentheses 3x plus 1. I had to get rid of that parentheses 3x plus 1 that's being multiplied to the y. So I'm just going to divide both sides. And let me go ahead and add that work that was done here. I said divide by 3x plus 1 on both sides of this equation. That's going to cancel this guy and gives you y equals and this new expression, right? Now, when you try to graph these, let me go ahead and warn you, if you try to graph both of these on the same graph, it's going to be kind of messy to see, but they are in fact going to be inverses of each other. But the last step, even though you got to solve for y again, is to write as f inverse. So this is going to be your last step. So your final answer is that the inverse of my function is equal to 5 minus 2x divided by 3x plus 1. This was a more complicated equation on purpose, because if you can rewrite a complicated equation as an inverse and create the inverse from a complicated equation, you can certainly do that with a simpler equation such as y equals like 3x minus 7 or something like that.